make it to class, so I'll record the session there. What we're going to be looking at today is how to solve for x. And we saw what x was last time. X is a variable or an unknown number. And the thing with that is you want to try to identify x. And we looked at identifying it through basically two different approaches. One is we're given a kind of riddle. X appears in an equation like this. I'm going to use the box symbol for variable. So we've got some unknown number. We got to figure out what this unknown number is. Again, this is that riddle where you're down in the bottom of the cave of Gollum. You got to figure out the answer to the riddle. And so you toy with it. You say, well, thinking back to multiplication, 3 times some number gives me 6. What number could that be? You say, well, it's got to be 2, if I recall correctly. So we discover that the unknown number is 2. Fair enough. Now, the other way we dealt with unknown numbers is that we gave them a value. We identified them. We said, x is going to be 7. When x is 7, what happens to our calculation? And that's what we call an algebraic expression. Today, we're going to be focusing on this. We're going to try to discover x. We're going to try to discover the value of variables. So far, we've been using a technique called guessing. Or if not, we call it informed guessing, where we use our knowledge, say, of the multiplication table to say, well, really the only possible answer I could see is 2. We're going to look at situations where we don't have to guess. We have techniques that prevent us from doing that. Now, the way these techniques work, they're based on the idea of an equation. Excuse me. And an equation says both sides of this equation, of this equal sign, have to have the same value. So both sides have the same value. So for example, here's an equation with 2 different looking sides. But if we look at these 2 sides, how much is on this side? Well, there's 3. How much is on the other side? Well, there's also 3. What an equation is where the quantities are balanced. That's an equation. So let me give you an example of what we mean by balanced. I'm going to draw this a little differently so it doesn't look like 11. So let's say I have 2 pounds on this side. I have 1 pound and 1 pound on the other side. They're equal when they're perfectly balanced. Now, what we could do is we can add and subtract weights to these sides. But to keep things balanced, what we do to one side, we have to do to the other. So let's say we're going to do this. I add 3 pounds to both sides. Well, barring artistic license, if you will, sort of random artistic license, you have 5 pounds, and you still have 5 pounds, 3 plus 1 plus 1. So we call this the addition property of equality, where if we add both the same amount to both sides, things still balance. So this is how we think of it in terms of weights and scales. How does this look for equations? Well, equations, you'd have something, say, like this. So we have 8 on this side and 6 plus 2 on the other. Now 6 plus 2 is 8. So we just add 3 to both sides. So I can get 11 on this side. Let's say I don't combine any numbers on this side, just write them out. But I still have the same quantity. 6 plus 2 is 8. 8 plus. Or you could just leave it like this. It's still going to be all right. I'm just going to remind everybody, just make sure you have your microphone and your camera turned on. Because everything you do, we can see and hear. And I think sometimes it'll minimize the screen. It'll make it hard to see the dry erase board. But if you have a question or a comment, you can switch on your microphone and your camera. That's okay. All right. So that's the addition property of equation. One take. All right. So let's consider another situation. Again, we've actually got 3 pounds balancing on either side of the scale. They're stacked differently, but that's okay. They'll still balance. Let's subtract 2 from both sides. If we subtract 2 weights or 2 pounds from both sides, we have a pound and a pound. And we can call this the subtraction property of equality. So when we subtract 2 from one side, we've got to subtract 2 from the other. So how does this look as an equation? Well, as an equation, you just subtract 2 from both sides of the equal sign. So 5 equals 4 plus 1. Same quantity on both sides. So if we subtract 2 from both sides, and we could subtract 2, say, from, well, you can follow your PIMDOS and compute that. You start left to right is what you would do. And so for the final answer, you get 3 equals 3. So this or this is where it's cleaned up. But we're going to subtract 2 from both sides. Now let's consider this situation. Again, we have 1 pound on each side. It's all balanced. Let's multiply both sides by 3. Remember, we have to keep things balanced. So if we triple this side, we have to triple that side. And so things remain balanced. We have 3 pounds on each side. This is the multiplication power property of equality. So this one we have to be kind of careful when we get to the equation. I'm going to clean this up at the end. But when we multiply, we're multiplying both sides. We're not just multiplying one number. When we add 3 to both sides, say for adding 3. But when we multiply, it's going to be the same thing, but it's going to look different. So 8 equals 6 plus 2. We're going to multiply both sides by 3 times 3 equals, and remember, we're multiplying both sides. It's the sides that's going to matter. So we'll get 6 plus 2, but we're going to multiply the entire side by 3. We have to multiply the entire side. And now, of course, here we got to distribute. We don't have to. I mean, we could follow PEMDAS and do the parentheses. We could do that also. But what we're going to get is 24. And let's say I distribute it, just because. Well, you're going to get 24. 18 plus 6 is 24. When we do addition and subtraction, it looks like sometimes we're adding or subtracting to just one number. We're really not. We're adding and subtracting to both sides. And then that becomes more apparent when we do multiplication and division. So we're balanced again, 3 pounds on each side. Let's divide by 3. So by dividing by 3, we're going to reduce this to 1/3 of what it normally is. We're going to reduce the weight to 1/3. But if we reduce it on one side to 1/3, we need to reduce it on the other side to 1/3. Oh, wrong symbol. And once again, it's balanced, 1, 1. This is the division property of equality. So there's a grand theme in all this, and I'll do an example. And again, we're going to be approaching the sides. In other words, we're going to be dividing the entire sides, not just one number. We're going to divide the entire side by 2, not just one of the numbers. Now, by coincidence, this side has only one number, but we're still dividing the entire side. This side has 2 numbers, so it becomes more obvious that we're trying to divide the side, not just a single number, actually. So what we're going to get now, technically, if you wanted to, you can distribute this division. Now, that might seem kind of strange, because last time we saw what distribution was, it was from multiplication. But we're going to see later today, you can treat this as a kind of multiplication. We've mentioned this before, but it's kind of obscure. So what we could do, you could take these, you'll get 4. If you follow PEMDAS, 6 plus 2 is 8. 8 divided by 2 is also 4. So you'll get the correct answer. Questions about that? So the grand theme is this. what you do on one side, you must do on the other. So any questions about that? So before we start solving some equations, we need to talk about an idea called cancellation. So we talk about cancellation, we're dealing with what we call opposites, or when operators, operators are addition, subtraction, multiplication, and division, when they undo each other. So for example, addition is the opposite of subtraction. Let's say I have nothing, and then I get $3. Well, the opposite of that, what you would do to undo that, is take away $3 or subtract $3. That returns me to 0. So addition and subtraction are opposites. If I'm in debt $10, you subtract $10 from my $0. Well, then to bring me back to 0, to return me where I was, you give me $10, and I can pay off my debt, and I'm back to where I started. So again, addition and subtraction are opposites. The other opposites, multiplication and division. So if I double something, if I go from, say, 1 car to 2, well, to go back to the original car, I take the 2 and I cut that number in half. Now I'm down to 1 car. So division will undo multiplication. Multiplication will undo division. If I have 3 pizzas, and you divide it up amongst 3 people, including myself, me and 2 other people, I'll have 1 pizza for myself instead of a 3. But then if you multiply that 1 pizza I have by 3, I'll have 3 pizzas now. So multiplication will undo division. So these are going to be opposites. We're going to use this for this idea called cancellation. Now, why do we even use cancellation? Let's go back to equations. X is our most popular symbol for an unknown number for various reasons. But it's a number for sure. We just don't know which one. Now, believe it or not, you've been solving for X your entire career. The difference is where X was showing up. So in this equation, we don't know what X is. But if we do these computations, then this is what we're going to get. Well, lo and behold, X is equal to 20. Now, what does this mean? Well, let's go back to our scale. Now, this equal sign says this scale is balanced. This weight is 20. This weight is just labeled X. It's a weight, they just didn't tell us the number. But if these two balance each other, That's only possible if x has been truly identified as 20. So that means when these balance, we know the true value of x. So now we've identified x. So what we're going to get from this are two things. One, you've been solving for x the entire time. You just didn't know it. So when you solve the math problem, 1/3 plus 1/6, what you're really solving is an equation that says x is equal to 1/3 plus 1/6. And then once you compute 1/3 plus 1/6, which is, let's see, comes out to 1/2, you've discovered what your x was. The missing number is 1/2. If you do 28 divided by 7, what you're really saying is x, there's some unknown number when we divide 28 by 7. Now, what is that unknown number? So you divide 28 and 7, you get 4. You say, oh, the unknown number is 4. And so that's what we've done here. Now, here's the difference between algebra and arithmetic. So this is basically arithmetic. Just solve for x, we do all the computations, and then we'll get x is 20. That's arithmetic. Algebra. Algebra is when we move the unknown to be a number over here in the computations. And we already know what the computation turns out to be. So this is what you've been doing since the beginning. Now we're going to search for an unknown number on the other side of the equal sign. So how do we do that? How do we solve for x? Well, the way we're going to do it, if I'm going too fast, let me know, is we're going to get x on one side of our equal sign by itself. We get on one side of the equal sign. On the other side, there's a number balancing x. So you have x on one side, you have a number on the other. And since x is balanced by this number, well, that must be the value or weight of x. Now, what we're going to do is we're going to use this idea of cancellation to find x. So first off, x minus 3 is 5. So what we can do, we want to get x by itself. So we want to cancel the subtraction of 3. Now, what's the opposite of subtracting 3? If you take $3 away from me, how do I get back to my 0? If I had nothing, you took 3 away, and now I'm in debt. Well, how do I break even again? Well, you can give me $3, and I'll pay off my debt, and I'll be back at 0. So we can add 3, but what we do to one side, we have to do to the other. I'm going to write this a little differently. So negative 3 plus 3, that's going to be 0. And I'm going to make a little note here. X plus 0 is equal to 0, or x minus 0, however you want to think of it. Oh, not 0, I'm sorry. It's going to be just x. So this is how cancellation works. I add 3 to this subtraction of 3, and it breaks me even. I get back to 0. And then x plus 0, x minus 0, it's just going to be x. But then over here, I have to add 3 because of the equal sign. So if we do this, what we'll get, x equals 8. Questions about that? So let's say we got this equation. So the thing to do here, oh, let me put a different one. I already did a subtraction. Let's do a plus. So if I'm adding 2, and I want to get x by itself, I need to do the opposite. I need to cancel this adding of 2. So I'm going to subtract 2. But what I do to one side, I have to do to the other. And so what we'll get is 2 minus 2 is again 0. And just to make a note, x plus 0 and x minus 0, however you're going to want to look at this, you're just going to get x. And then again, we did this here. We subtracted 2 from the other side because of the equal sign. If we take away 2 pounds on the left, if we take away 2 pounds on the right. Questions about that? All right. x over 2 equals 4. Now this one you can rewrite. You can say this is x divided by 2 is equal to 4. Because division and fractions, they're the same thing. So if we're dividing, we want to do the opposite. And the opposite of dividing is multiplying. So what's going on here? Well, what we're saying is that a division by 2 times 2, this turns out to be equal to 1. And just to make a note, x times 1 equals x. Or if you wanted to treat it as a division, x divided by 1, that's also x. But bottom line, this becomes a 1. And if you want to say, well, we're dividing or multiplying, x divided by 1, x times 1 will just give you x. So this cancels out. We're going to undo the division, and when we undo it, we're just left with x. It's kind of like if we have x dollars and we divide it in half, and then we have half of the x dollars. But then if we double half of the x dollars, we have x dollars back again. So that's really what's going on. You can think of it like that. It might be an easier way to think of it. And then here, we multiply by 2 on the other side because, again, to keep things balanced. What we did to one side, we have to do to the other because of that. Questions about that? So I'll do another one of these. Now again, x over 3, we can think of this as division. These are opposites, so they'll cancel out. If I have x dollars and I divide it into a third, then I multiply that third, I'm back to where I started, x dollars. But what change I make on this side that lets me do that, I got to make the same change on the other side. So x is balanced. We discover x to be 12. Questions about that? So real quick, I just kind of want to review a little bit about the differences between addition and subtraction of equality and then multiplication division properties of equality. So for the addition property, what we're going to do is do the opposite. But what we're doing is we're actually going to add 2 to this entire side. And this is what that looks like. And then we add 2 to this entire side. And so we get x equals 10. The same is going to be true for subtraction if we have something like this. again, we want to get x by itself. So I subtract 2 from both sides. Actually, let me write it one more time. So that's how we handle subtraction. And though it looks like I'm subtracting 2 from this 2, technically I'm subtracting 2 from this entire side. And when I combine that, what I'll end up getting, I'll take one more step to show you, is you'll get x plus 2 minus 2. And then, since we don't know x, and we can play around with PEMDAS, or we can use our tricks for associativity and commutativity to say this is plus and negative 2. But ultimately, these will cancel out to give us x equals 6. So any questions about that? For multiplication and division? Now what's happening, again, is we're actually multiplying both sides, but we're going to get this. And then finally with division. Again, the opposite of multiplication. And you can think of this as having a little multiplication sign in there, because that's what it means, 2 times x. Divide both sides by 2, we'll get x is equal to 4. And that's just sort of a rundown of what these things, using opposites to solve these equations, does. So any questions about that? All right, let me take a look at something, make sure I've got it all covered. We're actually we're a little bit farther ahead than the morning class. Let's see if we're just missing anything. So there are a couple things I do want to talk about, and they have to do with why multiplication and division are opposites, and how, in some ways, you can treat division and multiplication sometimes as a version of the same thing. So let's take this. X divided by 2 equals 4. Now, one way we can think of this is x divided by 2 equals 4. We're going to do the opposite of division is multiplication. We'll get x equals 8. So that's one way of solving this. There's another way. instead of saying this is division by 2, we can call it x times 1/2. Now, why can we do that? Well, consider this. 10 divided by 2 is 5. And then 10 times 1/2 is also 5. So what this says, 10 divided by 2 is 10 times 1/2. So that means if we have a division by 2, and I'll start this again. X over 2 equals 5. This is x divided by 2 is equal to 5. But division by 2 is the same as multiplying by 1/2. So this is x times 1/2 is equal to 5. Now what we can do, since this is originally division, we want to do the opposite of division, which is multiplication. So we're still going to multiply by 2. And the reason is that is still x divided by 2. The opposite of dividing by 2 is multiplying by 2. So you can treat multiplying by a fraction as the same as dividing by the whole number. Again, they're going to cancel. We'll still get x is 10. Now, questions about that. I've thrown in a lot of details to try to answer why things are doing what they're doing. But as far as just doing the problems, just knowing the opposites and then applying the opposite to both sides, that's going to solve your problem for you. The rest of it is just sort of details that kind of help explain a little bit why this stuff is working. Questions about that? So that's one thing I wanted to bring up. Another thing has to do with fractions in general. Let's say we have something like this. 1/2 x equals 7. Well, this is a multiplication. So you want to do the opposite of multiplication. So we're still going to divide. So if we're multiplying by 1/2 and we're dividing, they're going to cancel out. We'll get x is 7 divided by 1/2, or 7 over 1 divided by 1/2. Remember, you can turn whole numbers into improper fractions. So we keep the first one. This is our KFC. It's after lunch. Just anyway, moving on. Keep the first one, flip the second, change this from division to multiplication. We multiply across, and we'll get 14. Now, there are other ways of dealing with fractions. We're going to talk about those later. But even with a fraction, you do the same thing. Now, the alternative way of doing this one, though, multiplying by a fraction is the same as dividing by this bottom number, assuming that this is a 1. Now, if this is a 3, I would say just divide both sides by 3 halves. But if this is a 1, we can rewrite it as x divided by 2, and then do the opposite of division and multiplication, and then x is equal to 14. Questions about that? Now, this trick only works if you have a 1 in the numerator. If you don't have a 1 in the numerator, it's not going to work. Let's double check, make sure we've got it all. There's one last thing I want to go over. We're kind of finishing a little early today. Okay, maybe I'll do some more examples. And this last thing I want to go over is what we call like terms. So let's say we have this. So we have 3x and we have 2x. Now what we can do is we might say, well, hold on. This is as if we distributed an x. So we could say we took x and we had distributed it to 3 and distributed it to 2. So we're just going to keep working backwards. So we've gone from here to here, because if you distributed x to 3 and to 2, you would get 3x plus 2x. So let's back that out. We're going to reverse it. If we reverse it, we're going to get, well, this is 3 plus 2. Let's get x times 5, or 5x. Now here's the key part. What we get is 3x plus 2x combined to give us 5x. So in general, this is what we can say. Because it looks like all we did was just add the 3 and the 2. If we do that, that's going to give us our combined terms. So if we add ax plus bx, what we're going to get is a plus b times x. So let me do some examples. Well, 7y plus 2y in general will be 7 plus 2 times y. We're taking a shortcut is what we're doing. We could work this out the long way, like we'll reverse the distribution, but we sort of saw a shortcut. The shortcut is just add these numbers together to get the number that goes in front. We're going to get 9y. Questions about that? So what about this? Now, how do we handle this? Well, it's very tempting to just add up the 4, the 2, the 7, and the 3. But is this for the x or is this for the y? Now, the problem is we want to combine like terms. Now, what we mean by like terms, they're terms with the same variable. Now, why is that important? Well, the reason is x and y could be different numbers. They could be two different numbers. If we combine these to say 4x plus 2y is 6x, well, then the y became an x. So that means the y is actually the same as the x. But we don't know that. Same thing with 4x plus 2y is 6y. Well, now we're saying the x's are the same as the y's, and we don't know that. We don't know that. So what this means is we can't combine the x's and the y's. We don't know if they're the same. So they're not considered like terms. So we're going to combine those separately. So what we'll get (4 plus 7 times x), 2 plus 3 times y, or 11x plus 5y. Again, if we try to mix the x's and y's, we're going to assume then that they're the same, and we don't really know that. Now, if they are in fact the same number, we would just relabel the y's as x's, then we just change them over, or change the x's to y's, and then we could combine everything. But since we don't know that for sure, we have to assume that x could be different from y. So we don't want to say that one is equal to the other when we don't know. So for that reason, we combine them separately. This is also true with numbers in constant terms. I'm going to put known number. That actually says constants, believe it or not. Variables are numbers. They're just unknown numbers. So when we have unknown numbers with known numbers, if we combine those, that's saying that the unknown number is the same as the known number. We don't know if that's true. So if we have something like this, for example, two x plus 1 plus 3x. We have two numbers of type x and three numbers of type x. So we get 2 plus 3x plus and just the number 1. Because if we combine 5x and 1 to get, say, 6x, what we're saying is that this would have to be an x, or x equals 1. We don't know that. That we haven't been told. So we leave it like this. It's as far as we can go. Likewise, if we say 5x plus 1 is equal to 6, we're also saying suddenly we know what x is. But we don't know what x is. We have to be told what it is, or we have to use an equation to discover x. We don't have an equation here, so we can't discover x. So we just have to leave things like that. There's some unknown number that could be 10 for all we know, times 5 and then increase that by 1. And that's the best we can do. Questions about that? So we're finishing a little early. I think we had kind of more of a warm-up factor in the morning. Let me see. I don't know if I want to get you too far ahead of the morning class. So one thing, let me see, there's one thing I can show you that's going to help for section 2.2. I have to make sure to cover this for the morning class, just in case you have friends in the morning class. What if we have this situation? Now we have x's on both sides of the equation. The examples we had before is we had numbers on both sides of the equation. We do that here. But now we've got x's on both sides. What do? Well, we want x on one side. Because remember, we want x to be balanced by some other number, and that tells us the identity of x.
The screen is really blurry.
Oh, let's wait a second. It's probably the connection. Is it improving?
No.
Okay. Well, maybe we'll take that as a sign. We'll stop here then. So we're going to stop early. Again, I usually don't like to do this. So we'll stop early. We'll leave off where the morning class left off. And then what we'll do is I'll meet you for lab at 2:30. And then we'll pick up where we left off. What we're going to do in lab is I'm going to put some problems on the board. And there'll be about 4 problems where you solve for x, and then you'll have a combining like terms problem. Do those questions. Write a Blackboard message in your lab section, preferably. And send me your answers. And then use the rest of the time to work on your homework. And if you have any questions, like you get snagged on something, like especially these percent questions, like there's a really good one where you have to convert 66 2/3% into a fraction. That's a good one. That's a fun one. So if you've got questions like that came up on the homework or come up in the homework as you're doing them, let me know, because that's really what the lab is for. So other than that, we'll just stop right here. This leaves us about where the morning class is. And I will see you at 2:30, maybe turning off the camera and the computer will sort of reset the connection. Now again, a little bit ago it was kind of cloudy outside. Sometimes if it gets stormy, I the internet kind of goes down. So then maybe that's part of it. But we'll switch it off for now, and then we'll reconvene at 2:30, and we'll do some lab work. And I'll see you in lab.
I just have one question.
Yes.
Okay, so